In the final part of the notes, we want to solve the quadratic equation, and then once we get our solution or solutions, we want to check them by plugging them back into the original equation. And so what we have here is 0 is equal to 5x squared plus 25. And notice that this looks very similar to the equation that we started the day with. Notice that there is no x term. There's an x squared and a constant term, but there is no x term. And so whenever this is the case, we're going to use the square root method by moving that constant to the other side of the equal sign in order to make it negative 25 is equal to 5x squared. And then we're going to get the x squared by itself. In this case, that means we need to divide both sides by 5. And so this is going to end up giving me negative 5 is equal to x squared. When I take the square root of both sides, that's how I get rid of the squared. So I'm going to take that square root of both sides. And so I'm going to have to end up here with x is equal to. Now, whenever I take the square root of both sides of an equation, I need to end up with two solutions, a positive and a negative solution. And this is going to be the square root of negative 5. But we're not going to leave our answer like that. We're going to simplify the radical like we did at the beginning of the notes. And so what we're going to have here is x is equal to plus or minus. Since we have a negative on the inside of the radical right here, we know that's going to come out of the radical and just become an I. And so this will be positive and negative, the square root of 5i. And notice that the 5 stayed underneath the radical because it was not a perfect square, and there's no way to simplify the square root of 5. Now, if we plug this into the original equation, let's just do it to the right-hand side and show that it equals to 0. And so if we go ahead and plug in just the positive solution first, the square root of 5i, 5 times that squared plus 25. We know that whenever we square a number like that, we're going to have to square both items in the parentheses, and so the square root of 5 squared is just going to give me 5, and then I squared will just look like the way it sounds as I squared, and then don't forget the plus 25. Now, when we multiply 5 times 5i squared, we can multiply the 5's together to get, let's see here, sorry about that. We can multiply those together in order to get 25i squared plus 25. And now we remember that I squared in this case is equal to negative 1. And so that's going to turn that term into a negative 25 plus a 25 is equal to 0. And so we end up seeing that this solution of positive square root of 5i does satisfy the original equation, which means that it is a correct solution. I'm going to let you try to plug in negative square root of 5i into the equation and see if it satisfies that original equation, just like I did for the positive solution. For letter B, we again want to isolate that x squared term first. And so that means we're going to move that negative 10 to the other side. And so it's going to become positive 10 combined with a negative 18 is going to give me x squared is equal to negative 8. Again, here we will take the square root of both sides and get x is equal to a positive and a negative square root of negative 8. Now, we want to simplify this just like we did before. So this is going to be positive and negative, the square root of 8 times I, since in order to get rid of that negative under the radical, we just simply move it out as an I to the outside part of the radical. And now we want to try to simplify the square root of 8. Since it's not a perfect square, we need to think about all of the perfect squares that are smaller than 8. And so if we start with the first one that's smaller, that would be 4. And if I divide 8 by 4, I am going to get a whole number. And so therefore, I can rewrite the square root of 8 as the square root of 4 times 2i. And so now that we have a perfect square under the radical, what will happen is that that 4 will come out of the radical and become its square root. And so the square root of 4 will become 2, and so this will be plus or minus 2. 2 is this 2, I should say. This 2 right here is not a perfect square, and so it has to stay underneath the radical, and then don't forget about the I right here. And so we have our two solutions right there. And so we are ready now to check them back into the original equation. And so starting with the positive solution, we're going to have 2 square root of 2i all squared, and then we'll just say minus 10, and our objective here is to show that this is equal to the right-hand side, which is negative 18. So when we do 2 times square root of 2i times itself, 2 times itself gives me 4, root 2 times itself is 2, and I times itself is I squared, which I'm going to go ahead and write as negative 1. And then don't forget to bring down the minus 10. And so what we end up getting in this term is 4 times 2 times negative 1, which is negative 8, minus 10, which gives me negative 18. And again, remember that that's what our right-hand side said, and so therefore we can say that positive 2 square roots of 2i is a correct solution. I will leave it to you to plug in negative 2 square roots of 2i and show that it is also a correct solution.